All right, so a description of how we're going to record the perpendicular distances during a distance survey. So let's assume that we're going to be walking along a street doing our survey for blue jays, and this is the sidewalk that we're going to be walking along, and we're going to be walking in that direction. And we'll slowly be walking along, and maybe we see a blue jay while we're standing here. Okay, we see a blue jay there. Lovely blue jay. All right, and so the way that we are going to record the distance to that blue jay, we're going to record a perpendicular distance to the sidewalk, to our transect line. And we're going to call that X. Now, we can do that two ways. We can watch carefully as we walk, and we can get up closer, and we can actually stand where that 90-degree angle is to the location of where we saw that bird with the transect line, and we can use our laser rangefinder or estimate how far it is from our transect line to the bird. The other way that we could do it is to actually take the distance from where we stand, we'll call that R, okay? And if we're going to use this method, we also need to take the angle, theta, between the line of sight to our bird and our transect line. So we've got our handy compass down here, and to do that we need to see that indeed our transect line is lining up with our compass here, and the bearing of our transect line, the compass says that's 350 degrees. Now if I come over here and lay this in the field, I would just be holding it and doing my best to approximate that to the bird, but we'll pretend we've got a little map here. I'm going to put red in the shed, and we can now see that our bearing is about let's say 27 degrees. Okay, so we have 27 degree bearing. We had a 350 degree transect line. To make this work, we need to remember that 350 degrees to get to 0 was 10 degrees, and then we've got 27 more degrees. So we've got 37 degrees is theta. So our 37 degree, our angle between our transect line and our bird in that case was 37 degrees. And then we use trigonometry using the sine equation that we've provided you to determine, knowing the distance r and the angle 37 degrees, we can use the sine equation for a triangle and calculate x. So that's a little harder, but you can take the distance immediately, or you can slowly walk up, remembering where the bird was because it might have flown away since you first saw it, and you remember where you first saw or heard that bird. That's important. The first time you saw it. If it flies closer to the line, flies away from the line, you remember that first location and take the distance, perpendicular distance, with the rangefinder, or estimate it when you get up to that point in the line. So those are the two methods.